Okie dokie, welcome back to the SwiftUI tutorial series, where in this part we're going to be talking about SwiftUI, and, well, we're finally going to be starting talking about SwiftUI. Now that we've got an Xcode project set up, we're going to actually talk about what SwiftUI is, how it works, and why it's better than what came before. So, a little bit of context. So, what came before SwiftUI was what we call UIKit. So, in iOS, for the last 12 years, since iOS was initially born back in 2007, we have been using UIKit as the primary way of building UI in apps. So it was originally taken from Mac. So the system used for making Mac apps was called Cocoa. So it was called something. And when they developed iOS, they basically took the best of Mac and they moved it over to iPhone and they called it Cocoa Touch. Cocoa Touch. Anyway, it's basically what was there on Mac. They took the best parts of it, moved it to iOS, made some changes, so it's slightly better actually than what was on Mac OS or Mac back in the day, and still I think better than what's on Mac now. So that has been the way of making apps for the last 12 years. And with the advent of Swift about 5 years ago, Apple have been slowly moving a lot of their core frameworks over from Objective-C based code to Swift-based frameworks. So this has been a while in the coming, and they have finally, I think, with the sort of stability of Swift, it's been quite a young language, and only recently has it really become kind of fully fledged and what they claim stable. And so now with that, they have moved their UI frameworks into Swift. And rather than just porting what was UIKit and making it a Swift framework that still does everything the way UIKit does, they decided to completely rethink how they do UI. And so what is SwiftUI? SwiftUI is an innovative, exceptionally simple way to build brilliant user interfaces across all Apple platforms with the power of Swift. Yeah, I just read that from their website. But effectively, it's kind of true. It's a very flamboyant way of saying that it's a simpler way of writing UI code. If anybody out there has got any experience using React, it's very similar in a lot of ways to React in that it's a declarative language. So it's we'll just jump into some code because if you've used React before, then this won't be that unfamiliar to you. You effectively have a structure with a name, and it conforms to the type view, and that structure will have to have a computed variable called body, and that's not what I want. That computed variable, you return whatever you want your view to do. So in this instance, we're just returning a simple text label, and that's what's being drawn on the view. Now, how this works is effectively every time your view needs to update, the system, the SwiftUI framework underneath, will call this method, and whatever you return from this method, it will then render out views. Theoretically, you're still using UIKit because all that's happening here is this SwiftUI view will be getting converted into UIKit code and represented on the device like a UIKit view would be presented. As far as the end result is, it's exactly the same as building it using UIKit. It's only for the coding side of things more beneficial. So why is it beneficial? To be fair, it's just smaller in general. So that's 5 lines of code there to produce a label. I challenge anybody to write 5 lines of code in UIKit that does this. It's to have only 5 lines of code represent a label. Now, where this gets really powerful is with lists, and that's what we're going to go into in the next part of this tutorial. So I'm not going to go into any detail on lists right now, but where I think lists really represent or demonstrate how SwiftUI has changed the game, and how much more simple it has become to build table views, because previously you would have to have 20, 30 lines of code to write a table view, and now you can do it in about 6 or 7. So it really is much more simple and much more condensed. And because it's a declarative language, it's a lot easier to read for the for the programmer coming on to write these views. So if you imagine you're somebody who just came into a new company and you have to sit down and work out what this view does, it's much easier to read one method that tells you all of the layout and all of the content of your view than it is to have 20 different methods with delegate methods and all this other stuff going on at the bottom to work out what the view actually is doing and how it works. So the declarative nature of it is that it's supposed to be easier to read. It's supposed to be basically read like it would if you were in English. So for instance, if I had a text here and I wanted to set the font, I can just do title. I can set the font to title, which it automatically is live updating this preview over here, which you can see made the text bigger. So if I just comment that out again, you'll see it goes back to being small again, and then if I do it again, it goes back to being big. I can do bold. Bold. There you go. Makes it bold. I can do italics. I can do underline. There you go. So, and as you can see, it's automatically live updating this preview, which is something you never got with Swift with UIKit either. So this is a really powerful new tool that they've added with SwiftUI and Xcode 11. And as you can see, this is really readable. I want a body, I want a text with hello world, I want the font to be title, I want it bold, I want it italic, and I want it underlined, and there you go. So that is how the declarative nature of this SwiftUI language is working, and that you want it to be as readable as possible for anybody coming on and working out what your view is doing. So if I take that away again, we go back to having just our text. What it's also done is it's consolidated what we have in terms of layout. So up until now, we've been using a framework or a system called auto layout, which allows you to basically say, I want this, for instance, this label, I want it to be pinned horizontally in the center and vertically in the center, and that's how it's being done here. So by default, that's what any view in SwiftUI will do. It will pin itself to the center of your view. Now, if you, for instance, wanted to have two labels, one on top of another, the label underneath, when you were using auto layout, would have to reference the other label and say, I want to be pinned, I want my top to be, let's say, 3 points underneath that label. And when you start doing that with a lot of labels, suddenly every label has to know where the last label, about the last label, and you have to go back, and every label has a constraint between them, which is gets pretty tiresome to add. Whereas with SwiftUI, everything is stack based. So again, if you know what React, if you've used React, especially React Native, you will know a lot about stack based layout views, layout systems. So effectively, it will always put things either underneath each other or horizontally or potentially on top of each other. So in SwiftUI, you have hstack, and an hstack will horizontally align things. So if I take this label and just stick hello world, and we'll just change that to 2, I'll change that to 1. There you go. We now have 2 labels, hello world 1, hello world 2, and they're horizontally aligned. If I change that to a V stack, they will now align themselves vertically. And if I was to change that to a Z stack, you will see that although it's not very obvious, they're actually aligned one on top of each other. So if I was to change that to having that line there, you can see that there's definitely some weirdness going on there, and that's because they're on top of each other, effectively, directly on top of each other. So that's how the stacking, the layout system now works with SwiftUI. It's a bit of a change to what people are used to with auto layout. If you're really good at auto layout, you could do some really powerful things. Stack views slightly limit in some regards, but are very powerful in terms of just getting stuff set up and just making things work initially. So to do, for instance, especially if you were to just do this in code, if I was to have a bunch of labels in there, having them all vertically aligned like that and having them all spaced using auto layout, just using auto layout would have been a right pain. And it's, if you wanted to, for instance, add, so let's say we have this label here and we want to add a new label in between them, it's called 3. Previously, oh, okay, I see what's happened here. So there is actually a limit in the number of views you can add inside a stack. So in this scenario, we've actually hit our limit. It doesn't mean that we can't go more than this, it just means we have to do it in a slightly different way. I'll get into that in a second, but effectively, if going back to what I was talking about, if I wanted to add a label between 2 other labels, I would have to change the construct, move all of these ones down, add the label, put this from this label to the one above it, I'd have to add a constraint to that, the new one, and then add a constraint from the new one to the label above it, and it's just a pain. Whereas in this, you can just paste a new label in between, and it just kind of works. So yeah, for that, it's really powerful for basic, simple layouts. As I said, when you get into some more complicated things that designers like to do, it does start to get a little bit more finicky. But yeah, it's for simple stuff like this, it's really powerful. You've also got this over here, which is your attribute inspector. Now, anybody who's used UIKit in the past with storyboards, you'll know that you have all of these things you can play with. Now, this, by default, you'll have some basic stuff that you can add and change. So, for instance, we've got padding. So we can add padding around our label. As you can see, it will automatically add the padding around it. And as I change this, it will automatically add the code into your view for you, so that you can actually do this without having to code anything. So if I wanted a padding on the bottom of that, I would just add that, and as you can see, it's added padding.bottom. So it automatically adds some padding for you. You can do it either way. You can either change the code, or you can change over here, and you've also got some really powerful modifiers here. So you've got a whole list of different things you can change to modify your views. So let's just add a blur. So why not? And as you can see, you can blur text. Now, doing it with a simple modifier like that is amazing. To do that in UIKit would have been a load of work. So to be able to do it with just adding effectively 1 line of code is super powerful. So going back to where we were, as you saw a few minutes ago, I hit the limit on the number of views you're allowed inside a stack. So there you go. So extra argument and call. So effectively, a VStack has a max of, what's that, 10? 1, 2, 3, 4, 5, 6, 7, 8, it's 10 items. So as soon as you hit more than 10, you will get this argument, this complaint here that you've got an extra argument in your call. So how do we fix that? So what we can do is we can actually do a for each in here. If I was to do a for each, what we're saying here is we want a range of 1 to less than 20. So here we go, we've got all these labels here. Now, it's a lot of labels. If we want to make it really obvious as to what each of those labels are, we can actually add a value into our string here, so we can actually pass a variable into the string. So in this case, we're actually going to do label number. So this label number will go 1, 2, 3, 4, 5, 6, 7, 8. As you can see, there you go, 1, 2, 3, 4, 5, 6, 7, 8, all the way through to 19. So if we were to change this to, say, 200, we should get labels all the way through to 199. Now, you're not going to see that because it's way off the bottom of the screen, but that is basically a way of adding far more values to a VStack than you originally had. Now, we're not breaking anything because the issue really lies in how many operations you're passing into your VStack. So in this scenario, we're actually still only passing 1 operation, which is this for each. And in the for each is creating labels which are being added to the view using that. So it's basically, if you want to have tons of views added to a stack, then for each is the way to go about that. You can also just use a list. That's another way of doing it. But yeah, that's kind of the way of getting around the limit on stacks and how many operations you're allowed to pass into them. I've been talking a lot about these content previews over here. Now, over on this side, you can see here we actually have this previews struct at the bottom. If I was to delete that, the preview disappears because there's nothing there telling you what we want to preview. So if I was to click create preview, you can see it basically adds back the exact same thing. By default, it will only add this little text here, So when I try and run that preview, I'll just get whatever is passed into this struct here. So if we want to preview our view, this content view, we will add content view and we'll just create a new version of content view. And then when we preview it, you can see everything there. I'm just going to change this back down to 20 again so we can not got a million labels on the screen. What we can also do is you can actually run these previews live. So we'll build it out and run it like it would be running on the simulator. I'll use the one that's actually showing something. The difference between this is it's actually interactable. So if you have a button that does something, you'll be able to select it and you'll be able to see the change when you tap that button. Okay, so I've added this toggle view here, which, as you can see, if I was to select that on this view, I can't do anything with it because I'm selecting it for editing purposes, so I can add padding to my toggle, but I can't select the toggle, I can't change the value of the toggle. If I add padding to the left and right, it looks a bit better. Can't change the value, it's just kind of set there, it's just for editing. But if I was to click this little run button here, it basically builds out the view as it would be running on a simulator, but without having to load up a full simulator to do it. And now you can see I can select and toggle that view. We are using something here called a state variable here, which we're passing into our toggle. Now I'm not going to go into detail on that because I'm going to do that a bit more detail later in the series. But effectively we have a variable here that's set to true. So when we first run it, it's enabled. When we hit the toggle, we pass that value into the toggle. So when we change that, this toggle value will automatically be getting changed for us. So we can turn it on and off, and this value here will be getting changed for us. It is something we'll go into a bit more detail in, this state stuff, but effectively it's a way of redrawing your view when something changes. So when a state value changes, this method here will be recalled by the system, and you can change anything based on that. So for instance, if I wanted to change, let's just get rid of our for each here, and we'll just have a text with hello world. Get rid of that. Hello world. So there you go. So we've got hello world there. And if I was to say, for instance, toggle value, question mark, and then other, and we'll have, let's copy that again. We'll paste that in there. Hello universe. So in this scenario, if toggle value is true, we show hello world, and else if it's false, we'll show hello universe. So if I give this a quick little run here, if I disable that switch, as you can see, it automatically changes that text with no code needed at all to actually tell it to change that. If I was to select this in UIKit and want this label to change, I would have had to add an observer to this switch, this toggle here, which would then change this value. So we would have to actively be observing this switch, which is it's not a ton of code, but it's extra code that you'd have to maintain. Whereas here, it automatically gets re-rendered when this toggle value changes. So by changing this switch, it changes toggle value's value, and it then automatically recalls this method, which re-renders the view. And because toggle view is directly related to which text is shown here, it will automatically update your text for you. So it's really powerful for stuff like that, for changing UI based on state. You just have to change the state and the UI will automatically update for you. It's really powerful. But yeah, as I said, I'm not going to go into any detail on state objects at the moment, or there are several other of these property modifiers that you can add to a value that will automatically update your UI, but I'll go into more detail on that later in the series. But yeah, I think that's probably going to call it for this. If you have any questions about SwiftUI, there's a lot we didn't cover. SwiftUI is very expansive. There's a lot to know about it. We'll go into a lot more detail on things when we're actually using them, but as a quick overview of how SwiftUI works and how the layout system works and how powerful it is, I hope that this kind of covered a lot of those areas for you. And yeah, we'll go into the next part, which hopefully I think will be about lists. So we'll be able to go over some lists and how they work, and kind of explain more of a comparison between AppKit or UIKit and how much more powerful SwiftUI is in terms of creating table views, because I think, as said earlier, it's probably the most obvious advantage of SwiftUI. It really highlights how much more powerful SwiftUI is over something like UIKit. So yeah, we'll go into that in the next part. So stay tuned for that. If you have any questions, leave it down in the comments. I'll try and reply again. I don't think I'm going to get very many comments. I mean, I'll be lucky if I get some views in this video, but yeah, early days. Hopefully people are actually interested in this stuff. But yeah, see you in the next part.